Welcome, everyone. Thank you very much for showing up tonight. And as always, we have one of the most gracious and awesome hosts ever. LinkedIn has been providing a space for free for several years now. And it's always not just small space. It's actually really large space, very accommodating space, and lots of free food. I don't think you can ever have a better host than LinkedIn's been for us for the last few years. So thank you again, LinkedIn. So our awesome MC, Jeff, is in Germany right now, so it would be a little difficult for him to take his normal spot up here, so I'm going to fill in for him. Also, this is different in a different way, that it is actually themed regarding to, hey, PyCon's coming up in less than a month, and so now's the time to start getting geared up for it, get a taste for it. And sometimes when we have people who've never heard of PyCon before, we want to give them a quick introduction. So if you've never heard of PyCon before, go ahead and raise your hand. Okay, cool. How many people have gone to or intend to go to PyCon this year? How many people are not going to PyCon this year? Oh, wow. All right, cool. So it looks like for the camera, the mix of audiences, we had a few people who haven't heard of it before. We had a few people who are going, and some of us are not going, but probably are getting their PyCon fix right here tonight. So PyCon is full of lots of great things. I don't think I've ever had more fun. It's usually a lot of talks, very much like we had 3 talks scheduled tonight, although our third speaker isn't here yet, so we may have 2 talks tonight. But at PyCon, you have days and days of just lots of talks. Your brain hurts because it's really so cool. There's auctions. There's what else? Help me remember all the pieces. There's a run, open spaces, definitely open conference, open spaces. What else? Sprints, of course, if you want to code together in sprints. Anything else I'm missing? Submits?
Summits.
Oh, summits. Yeah, like the educational summit. Yeah. Dinners. Yeah, I really like the dinners, and I actually like a lot of people I haven't worked with in a while are there, and I usually go out and spend time and dinner with people. So if you haven't had a chance to go to PyCon, I would go because it's really, really lots of fun. And we couldn't squeeze all of that in here tonight. It just isn't possible. So, oh, and there's lightning talks too. A lot of lightning talks. And running. So we're going to go ahead and just have 2 talks tonight, hopefully 3. And if there's room afterwards, we'll do the lightning talks too. So no auction tonight and no 5K tonight. Sorry about that. All right. So without further ado, I'm going to go ahead and invite up Moshe to do. Oh, did I lose it already? Sorry, I didn't wiggle.
Yeah, it's okay.
There we go. So the first talk is going to be about Amazon Web Services and how to automate those using Python.
Thank you. So yeah, I'm Moshe Zadka. I'm going to talk to you about how to automate your Amazon Web Service stuff. So we'll start with why automate. So you want to make it reproducible, right? If you can easily lose your stuff in Amazon, it's all non-redundant, so you want to be able to reproduce it easily. Also functionalities. There's actually some functionality that is not available with the web UI. Usually a little bit esoteric, but for example, you cannot connect to devices above, I think, G. So if you want to connect to like devxdp, you have to do it with code. And basically, the goal is that to treat their UI as read-only, right? You look at stuff to see what's happening, but you don't make changes to the UI. All your changes happen through code and automation. The UI is there to see if your automation worked OK. So this is like the correct way to use AWS, as I've learned in I guess a few years of working as AWS. So account management on AWS is complicated. So I'm going to start with a spoiler, which is like the result I'll get to after like a few slides. And then I'll go and kind of slog you my way to actually like the details of the spoiler. So the way to do it is to have one account that's basically billing only. And you give no root access to the other account, at least on a regular basis. Maybe you lock up the password in a safe for emergencies. And you'd probably want an account for production, for build, for staging, for demo, and for dev. So root account, and this is something that's very, very easy to kind of confuse. That's the same as the AWS account. So when you create an AWS account, you create it with an email. And that email is considered the root account. So whenever you log in with the email and whatever password you set up, you logged in as I don't think they call it root, which is very confusing, but it is the equivalent of root, which is at that point, you have every power imaginable. You're not bound by any policies, which is obviously very dangerous if you give that people on a regular basis. The other type of an account is an IAM account. An IAM account belongs to an AWS account. So an AWS account is both what you use to log in as well as a set of things. And among that set of things is one or more, or potentially zero or more, but really should be one or more IAM accounts. So the IAM account is part of the AWS account, which means someone else can have a different AWS account with a different IAM account. So if you have an IAM account of regular developer, that regular developer can also have an IAM account on a different AWS account. It's kind of subtle. IAM accounts in general cannot access billing. I think that was true when I wrote these words in my talk, and since then they've made some changes to the billing. So it's possible that now you can give permissions to IAM accounts to billing. I haven't checked that, but that's a pretty recent change of the last month or two. I probably should update that. It was true when I wrote the words. But most importantly, it has a security policy that it follows. You can say what an IAM account can and cannot do. You do not have to give an IAM account a password. There are many reasons not to have an IAM account that does not have a password. And we'll go through one of those. And I don't think I have time for the other one. But if you do want to have a password, you can have various password policies. But anyway, it's optional. You can set it up to use two-factor authentication. They definitely support Google Authenticator. I think they support most other things, but I haven't checked. But they're pretty good about supporting most common 2FA widgets, which you should probably enforce via your policies if you're actually doing anything important and you gave someone a password to an IAM account. You should probably set up two-factor, just kind of common best practice security, and that's for humans. So you probably have more than one person in your organization that wants to accessing, and you want to make sure that every single human person has a separate IAM account. So and even if they have the same policy, right? So if I'm working, I'm going to have a Moshe Zadka account, and if my colleague is working, he's going to have his own account, and we log in with different passwords and different 2FA. We do not, and we should not share the passwords and the 2FA tokens with anyone else. Even if we follow the same policies, at least this way, if you look at the logs, you'll see that Moshe deleted that super important machine that, right? So you'll know how to apportion blame or possibly praise. I've never seen it used for praise somehow. API key. An API key also belongs to IAM users. Much like a password, it is optional. Most human users do not need an IAM key, right? Because they'll do things to the UI. And as we mentioned, doing things to the UI usually should mean read-only. You might want to allow the policy of doing some actions for emergencies, but it really should be for emergencies. API keys are mostly what are going to do stuff, changing your environment, but they're optional. You can have more than one. Clearly, you can have zero because it's functional. You can have two. This is actually very important. And like I said, for robot users, so for your script that does auto-deployment, or for your script that does auto-scaling, or for any other reasons, like maybe you want a read-only robot account that does scanning of your environment and makes sure that everything looks okay. All kinds of robot users you can think of. And obviously, if you have two kind of different things with security implication, right? Maybe only some of your machines handle financial transactions, you might want them in a separate policy managed by a separate robot user. So I kind of alluded to policies several times already. So root can do anything. You literally cannot set policy on that account. This is why it's so dangerous. It's even more dangerous in Linux than Linux, I guess, because now we have SE Linux. But Amazon does not have anything like that. If you logged in with root, you can trash everything you want, which is not good. Admin, there's a default admin policy. It can do almost everything. I don't remember exactly what they disallow, but it's pretty billing. Thank you. I guess, almost anything. So it's pretty powerful, right? You might want to give some humans the ability to be admin just so they can handle emergencies. the policies are like very, very customizable. So I'll give you kind of a taste. Like I could have a very big policy, but then it would be hard to understand what's going on. So what I chose here is just a simple policy of you can do anything except touch IM users. Right, so that's a very typical policy because it's very reasonable to say, you can't add or create users because that's like a separate level of accounting, because then you can create a new user basically and then do things as that user, and there's no tracking of exactly who did it. So I don't want to do that, but you can, whatever you want to do with machines, that's fine. You probably know what you're doing. Not necessarily like a good policy, right? I'm not suggesting here best practices. This is mostly to give you a sense of like what kind of customizations are available. There's obviously more details than I can just talk about, but this is kind of a good high level. Consolidated billing is one of the most beautiful features AWS has because it lets you keep differences for the technical stuff, but letting the finance people just pay one account and actually having even better visibility than you would think. So I'm going to talk about that because in my experience, that was like, that was what gave me and like, the admin level people, like the CEO and the finance people, like a good way to talk about like what's costing us and where do we pay credit cards and stuff like that, which is very useful. Like you don't want these people mad at you. So you want to create a master account and then basically create sub-accounts after that. If you have previous accounts, you can actually retroactively link them, so you don't have to create them correctly. It used to be harder. It used to be that you couldn't create them correctly. You had to create them and then link them retroactively. This slide used to explain how to do that, but now I don't have to because you should just build them correctly from the beginning. It's easy to separate out the bill. When you give the bill, like when your finance people ideally log in manually and get the bill themselves, they can see which sub-account was responsible for how much money. So if the logical division between your sub-accounts matches something that the business cares about, the business has visibility into what they're paying for, which is always good from like as a technical guy to make sure that the billing people understand what they're paying for, so I can argue with them if that was worth it. So basically the way to achieve corporate awesomeness is have only admin finance people have access to the master account. No engineers should ever touch the master account. The master account is not for engineers. It's only for the admin and finance people. They might come to you with questions about stuff, but they are the only ones who should log in. No resources in master account. The master account should not be spinning up any resources because admin and finance people are not the correct people to spin up EC2 machines. You have production account for user facing, right? You keep proper users access to that. You have a staging account that usually tries to be mostly a copy of the production account, sometimes a scaled down copy because sometimes the production account just costs a lot of money and you don't want to explain why we're paying twice as much money to Amazon. So you sometimes make smaller machines, make fewer machines, make smaller disks. There's various ways to kind of try and save money on that. You want to have a build test account that always has to be a separate account. It is a production account, right? Because if that goes down, you cannot make changes to your stuff. It should be built separately. It should have different access controls on it. Usually I put build and test in the same stuff because what they share in common is that they're still completely automated. Like nothing manual should be removing or adding machines from the build and testing account. It should still be built up via one script that sets up all the machines correctly and makes sure that they're set correctly. And then a pets account. Pets is like, I guess like the kind of distinction is between cattle and pets, right? So pets are things you care about personally, right? If you have a cat, you care about that cat. It is not replaceable by other cats, right? If you have a cattle, you don't care. What? Carers might not care about you, and I'm not saying that those machines are going to care about you either. I'm not making any promises about machines. But these are machines you care about, right? This is your dev machine, or this is my 3-machine setup that's supposed to replicate some complicated problem I saw at a customer, or all kinds of stuff. So pets belong to people, and the people care about, and they might not have automated the creation of those pets entirely because it's not worth it, right? If you have a problem that you're trying to reproduce with from some customer, automating that is not necessarily smart, right? Like the whole reason is that you want to quickly like change this, change that, change this until you kind of got like the good replication going. There's no need to automate it. And once the problem is solved, you probably don't want to keep it. Maybe you'll want to keep it, but very likely you want to throw away that. Now you understand the problem. Maybe you'll have like a different application for your test environment of that problem. And your dev machine, again, you want to make a lot of changes to it in a small. You might want to back up your code, but again, often this is a pet. So you want to have decent policies, and the reason to have all these separate accounts is because you can have separate policies for these separate accounts, right? So you can say production, stage, and build. All the resources are automated, and they tagged with a reason, which is what business aspect are they feeling, right? Is it the build of the backend, the build of the front end? Maybe like, depending on how your corporate structure is, if you have different, business unit, what business unit is like, so that it's very easy to, like when the finance people come to you and say, why is it costing so much money? Because the finance people will come to you, of course, and say, why is it costing so much money? This is like a law of the universe. You can say, well, this business unit is responsible for that. Go fight with them, right? And that's true for both production, for staging, and for build. Like you'll be paying money for all of these, presumably. So you want to make sure that they understand why they're paying that money, and that no one, that people are responsible for, how they, account for money spent. Pets should be tagged with the developer name. And you want the policy of garbage collection by default, so that if I forget to garbage collect my pet, it's gone. And you tell your, so yes?
Default.
Huh, thank you.
Just because you're shipping later.
Yeah, thank you. Anyway, yes, so you want to garbage collect them by default, because otherwise people will spin up these like, M2 extra large machines, because they need like really a complicated replication of a problem, and then they'll go home because they're tired, because they worked really hard on figuring out the problem. They'll go fix it, they'll check in the fix, and they will never clean up the machine. So you want to basically GC by default, and you want to say, tag your pet if you do not want it garbage collected, with why, if it is your dev machine, say, this is my dev machine, do not garbage collect until so-and-so date. And then, again, you're kind of, so basically the idea that probably in the pet area, there'll be a lot of things being spun up, probably a lot of garbage. If you don't garbage collect by default, you'll end up just, kind of dripping money in AWS's direction. Then you'll be very sad when the finance people come to you and ask you why you're dripping money. OK, so now that we understand how to set up, OK, so we set up the environment. This is great. I told you should automate everything except the pets. So the pets are like, you have a few EC2 machines. That's fine. But OK, how do you automate? Botos3 is a library that AWS maintains. They actually hire a few great Python people to maintain that. So it's basically a first-party library that works really, really well. The documentation is very thorough, but sometimes hard to slog through. Sometimes the API is a bit confusing. Hopefully, I'll point out the places where it's more confusing than it should be. So to start with Botos3, you need an Amazon account and, of course, a robot account. It should be a dedicated robot account. You should not have an API key for Moshe Zadka. You should have an API key for some logical robot, like deployer bot or whatever. You do want to tag that bot with an IAM policy. You can theoretically set a policy directly on that bot. You should probably have a group and tag the robot with a group. But however you do it, that robot should have a specific policy that restricts the things it should do. If the robot should not be changing users, it should not have the permissions to change users. You generate an API key through the UI. You might have to log in as the robot for that. You might have to log in as an admin account that has enough permissions to do that. Different ways. Saving the secret is hard, right? So the Amazon key is made of 2 parts. This is actually very useful because it is really hard to save secrets, and it is made slightly easier by a decision that Amazon made to have basically the key made up of 2 parts. One part that is publicly shareable, that does nothing but identify the key. It's still like a hex string that is meaningless, but that you can see. Like this account has two keys. The first account's public part is this big hex string. The second account, so when you look at the key that's expired, you can say, oh, it's expired because I do not see that hex string in those hex strings. It would have been nicer if they let you choose a name, but at least they have some publicly shareable part that you can eyeball compare. So that's pretty nice. I do not have, in general, advice over where to keep the secret part. That depends so much on your personal, kind of corporate policy. Sometimes you want to back them up in LastPass and put them on laptops. Sometimes you want them in separate places. There's also like ways to do some of this stuff without an API key that I will not go into because they're more subtle, but I'll just mention that so you can go look at it. And maybe I'll have some time to talk about it in the Q&A. You can rotate those API keys. That is, of course, in general, an important security practice. And here's how you rotate them. So you can have up to 2 keys per robot account, right? So you generate the second one. You deploy the second one to wherever you deploy secrets. And you invalidate the old. You do not delete the old key. You invalidate it. Make sure that everything is still working. If everything is not working, revalidate the old key and deploy the second one correctly this time, ideally. Write like the wiki page better and invalidate it. Check that everything is working. Now that everything is working, only now do you delete the key. So this is like another great feature that Amazon has, which is you can temporarily invalidate an API key, and you should use it to make sure that your key rotation mechanism works. OK, so now you have a key. It is the correct key, and you've checked it. Your job is not done yet. We still haven't gotten to the point where I show you code, because there's still more stuff to understand about AWS, and that's regions and availability zones. And people confuse those a lot, so I'm going to try and explain that. So regions more or less correspond to geographical areas. People remember by heart the code that is like important geographical areas, like Oregon, where this talk will be given, is US West 2. California is US West 1. US East 1 is, I think, Virginia. And I don't think I remember by heart any more of those, thank God. But anyway, like they're basically coded, so there's always like a logical place name that you'll sometimes find if you look at the UI. And the logical name, the US West 2, is what you'll give to various APIs. In this case, say to Moto 3, you'll give US West 2. Availability zones correspond to data centers, usually with some physical distance between them. The idea is that if there's a power outage in some part of wherever in Oregon they have the data centers, hopefully it doesn't expand to the second data center. So there's US West 2A, or 2B, or 2C. They have a few data centers. It's very subtle. The correspondence between the actual data center and the letter is user dependent, which means if you have, say, a prod and a staging account, there is no reason to think that US West 2A in prod is close to US West 2A in staging. The mapping is arbitrary based on the, yes, I know it's very confusing to everybody, which is why I kind of like say that, because you can find it if you read enough documentation, but it is not easy to find it even if you read a lot of documentation. So it's important to know that, because you cannot assume that things are fast. Thanks. Wow, and I haven't even gotten to the code yet. EC2 instances are virtual machines. Those are like the most famous part of AWS. You'll probably spin up an EC2, unless you're doing very interesting stuff like S3 and stuff like that. You'll probably spin up an EC2 or a 3. They're the basic compute units. They're basically a computer in the cloud. That's kind of what made computers in the cloud be. There's various sizes and various costs. And I'm not going to talk through those things, because that would take another whole talk, and I already have 10 minutes left. When they spin up, most of them use a Python package called Cloudinit to initialize themselves. And what Cloudinit gives you is the ability to grab the instance metadata that you attach to the UI, if it's a pet, or the automation layer, if it's an automated, and make changes physically on the machine. Like the most popular thing to do is to set up probably the SSH authorized key. So if you set the instance metadata in exactly the right way, and you can read the cloud in its documentation for what is exactly the right way, then you can put in the SSH authorized key which key they should do it. You can actually have the whole hex pub key there, and this is actually much nicer than setting it up via other ways. So this is very useful. You can set up a lot of other things via cloud init. I'm not going to go through there because, again, I have to give a new talk. In general, you'll probably want to SSH to the instances. In the very least, to kind of check that they're like OK, but probably also to kind of initiate self-configuration. You can generate a pair through AWS. They'll keep the public part, give you the private part, and forget the private part. So if you lose the private part, you basically lost access to all these machines you configured very carefully. You can generate it yourself and upload the public part. They'll happily keep them themselves. Remember that the name is per region. Per region, not per availability zone. So US West 2, all the parts of US West 2 can share the same key, but if you upload the key to US West 2, you cannot use it in US West 1. You'll need a separate key. You can name them themselves the same. It might be a good idea or might not, depending on a lot of details. So here I don't have a lot of best practices, except to tell you you can do whatever you want. You probably want to think about that. A lot of people SSH into the machines and then press yes. That is wrong. Do not do that. Please, for the love of God, do not do that. There are actually attacks in production that people can deploy against you to hijack your connection and own your machines. And that is obviously not good. So what you want is to basically use the API, right? You've already set the API key correctly, ideally, to basically grab, as you can see, I basically grab the console output from the VM. I parse it very, very ad hocly. Yes, like see, I kind of just look for a line that starts with SSH RSA, and I shove it in my known hosts. But the point is, after I do that, I do not need to press Y. It is a known host, and if someone is trying to trick me, SSH will point out. I don't know if you ever seen like a scary warning from SSH, but it will point the scary warning. You cannot mistake it. It is very scary, and you should be scared. At that point, someone is probably trying to attack you, or you made a bug. Right, so I'll show you how the last line is supposed to look like. I broke it up for readability. It's already kind of hard to show it on a slide. I basically tell you the machine name, the IP, the protocol, and then like some big hex thing that I kind of alluded for so that you can actually understand what's going on the slide. AMIs, Amazon Machine Images. There's ready-made ones for CentOS, for the Amazon Linux stuff. You can easily make your own. You can share them across accounts. You need to do some things to share them across accounts, but you can. And that's very useful because, like, if you do generate your own, you probably want to generate them from the build account and share them for all the other accounts. All the other accounts can use them. You do not want to put secrets in them. They cannot be encrypted reliably. So you can put, obviously, code in them, but do not put, like, your auth key to SendGrid or whatever it is that you're using there. That is a very bad idea. Why should you build your own? You probably want to manage your own security update routines. You might want to install specific software. You might want specific configuration, like configuring SE Linux with whatever. There's like infinite ways to configure SE Linux, and you probably have some way. You can do it just by SSHing, obviously after setting up the security stuff, and then running a command like yum update y, and then basically calling boto3 with client create image. You can use something like Salt to basically do that. It is useful because Salt has dependencies, and if you do want to make sure that you update before you install Docker or stuff like that. OK, so now you have your AMI. Now you actually want to build some machines. Like I'm almost at the end of my talk. You want to use CloudFormations to build your machines. There are other ways you can use Terraform, but if you want an Amazon native solution, CloudFormation is it. It is a pretty good solution. We use it in production. CloudFormation templates are merely JSON files. You can parameterize them. Often a parameter is like key name or something like that that you want to change between accounts. You can self-reference stuff, so you can create a security group and reference it somewhere else. This is about the simplest template I could show you. It was hard to fit it on the slides. You probably won't get all of these things, but you'll see that I have an instance, it's T2 micro, I create a security group, I configure SSH to be allowed. It's not necessary to kind of see the details. It's like very dense JSON stuff. Just remember, with JSON stuff, it can define machines, it can define other things, and it can create relationships between them. You can, of course, just manually create the dictionary and just use JSON dumps at the end. Completely valid if it's simple enough. You can use Troposphere, which is a more civilized library to create it. It definitely helps a lot in making sure that your identifiers work and that you're not making stupid mistakes like misspelling your identifiers, which, of course, you won't discover until AWS is halfway through your CloudFormation template, and then it rolls back your CloudFormation template because security group foo is not defined, just foo1. That is a lot of fun. After you have the JSON dump of the dictionary, you basically use it like that. You basically push the stack, and you just wait, and then you wait some more. So ideally, you let the script do the work of waiting. It basically, as you can see, the script ends when the create is not in progress. Half of the time, it means that the create has failed because you've just changed your CloudFormation template, and obviously you made it invalid. If you have a new CloudFormation template, you can update it. The way to update it is to make a new JSON file. When you upload that, you can say, do not actually do these changes. Create a change set. Then you can actually eyeball the change set. I said you can use the UI for inspection. So you can eyeball the change set, and you can apply it. I'm going to skip over the VPC stuff and the S3 stuff because I think I do not have time. And the snapshot stuff, and go directly to the summary. Sorry. AWS is pretty complicated and has a lot of services. Honestly, if I talked through all of them, I'd be like 3 hours here. Do not do root logins. Use CloudFormation for everything if you're not using something else, like Terraform for everything. Automate everything. And that's it. Yes, you have the question. Yes, everything. Okay, thank you very much. Good eye. So we have 5 minutes for questions?
5 minutes for questions.
Awesome, yay.
So come here to the microphone. Please ask a question so it'll be on the camera. Is Ashish in the house?
I will remind you that the question is something you do not know the answer to.
Good, thanks. You have 10 minutes for questions.
Oh, woohoo.
Oh, yeah. I'm the first one, right? Thanks for the talk. It was really interesting to see the production piece. I was wondering, what's your take on the Terraform versus CloudFormation? I was using CloudFormation. It's really painful, in particular in editing JSON manually. It's kind of a painful thing.
Yeah, well, doing JSON manually is insane. You should use Troposphere if you're using CloudFormation at all. Then once you've kind of acceded to this is basically a Troposphere versus Terraform issue, I think there's some issues with Terraform in using it in production because it has this binary file that if you forget to kind of properly check it in, then it basically starts to diverge from the real environment, and you can really hurt yourself. Mm-hmm. So it might not be easy to make a mistake, but if you make it, you cause unbelievable amounts of pain. That is exactly the kind of thing that does not let me sleep at night. So all the pain of CloudFormation is at least bounded amounts of pain, which is much better. I think CloudFormation is working on having something that will basically able to recreate the binary file. And I think if they fix that bug, I'll be more open to people using Troposphere in production.
Okay, fair enough. So piggyback on that, kind of, you mentioned about Salt. So how about Ansible? Obviously, in the context of Python, we should mention this.
Sorry?
How about Ansible?
Sure, yeah. Salt, Ansible, all great. And if you are not bound to Python-based stuff, Chef, Puppet, basically every single thing that configures machines can configure an AMI because it's just a configuration of a machine. Usually, what my recommendation is use whatever you're going to use later. right? Whatever you're going to use to set up those machines post-creation, use it also to create things. That way, it'll be easy to move things backwards. And that is a very useful thing to do. You want to move as much things as you can to the AMI. It's probably not going to be easy, so you want to make sure that you have a framework in which you can still bit by bit from the stuff you do in production to the stuff you do in build.
Yeah, so kind of on these two things, so there is this problem of having this declarative versus procedural kind of way of, so I mean, like Terraform versus Ansible, right? So Terraform / CloudFormation, right? So there's this kind of fight, and I've seen even that LinkedIn kind of preferred now Terraform, at least one of the groups. Kind of there is a whole set of articles.
Yeah, there's arguments for both of them. I think they're both okay, right? Like you're not gonna really fail with either of them. I've explained why I've chosen against Terraform, which was a very careful decision. I basically want to make sure that I do not trash my environment if I do a miscommunication.
Okay.
Anyway, yeah. Okay, cool. Let's let someone else ask questions.
Hi, thank you very much for your talk. Very interesting. I have two questions. How do you do this garbage collection? What do you use to do that? Is it some kind of scheduled Lambda or some kind of CI machine like Jenkins or something?
So honestly, so when I had to do it, I literally just had a script and I would run it manually from my laptop. Like it would basically connect to the AWS and kind of clean it up. You can use obviously like anything that schedules, like so you can of course use Lambda. You can use CI from the build environment. It will poke it. Like so I don't have strong ideas. Like but honestly, like because I ran the garbage collection once a week, it was actually nice to do it myself. It wasn't like a huge overhead on my part, and this way at least I knew that when I'm doing that. So if people came and running in, I could actually email people and say I'm gonna do that. It was a smaller company, so obviously the situation is different in bigger companies. But it was actually nice to kind of actually come in the office, kind of see who's around, and only then do the cleanup. So I did it manually. Obviously you can schedule that however you want.
Right. Probably scheduled is better because if people know that it will happen, they will actually.
It really depends on your specific details, right? So
I'll give you 1 more hour to do this.
Sure. Yeah.
Anyway, the second one is you mentioned that you have different accounts for basically everything. You have pets, which is basically for development. You have build separately, and hence the question. You obviously have, let's say, some kind of CIs again in the build.
Sure.
And test, right? And so how do you? I mean, there are ways, and I know about them, but how did you connect all these accounts, and how did you make it possible that build account machines are able to do things?
I guess it obviously depends on what you actually build. So the build machines build AMIs and just made them available to the other accounts. And they also build Docker images and uploaded them to the Docker registry. If you have a Docker registry on AWS, I think you can set it up to it's available from a few other accounts. But we just use a hosted public repository. So in our like I said, and I think that's very. What's typical is that there is no typical. Like how.
What was your? I mean.
What we did was made the AMI. Images available to all the other accounts and uploaded the Docker images so that the things can download them whenever they want.
Yeah. So my experience was that, having different accounts was more of a difficulty than, convenience because, connecting.
So multiple accounts, to be clear, multiple accounts are not for convenience.
I mean,
multiple accounts are for so that the pets will not be part of the build, so that if there's a cost overrun by the pets, it's very obvious, that we should tighten up GC policies. And if there's a cost overrun with the build, we should probably rethink our CI strategy and how big our machines are. Right? You want to be able to differentiate them, and you want the finance people to kind of be able to differentiate them. So this is kind of it definitely makes things less convenient to separate out to the accounts. What they give is more security and better visibility for the finance people. Okay, let's let someone else ask questions. I've been waiting patiently. Thank you.
Hey, thanks for the talk. You talked a lot about where not to store secrets. Where do you store them?
Oh God!
Yeah, it's painful.
So like I said, like I didn't actually even say what not to do. What mostly I said was that you probably should consult your your local secret management expertise, right? Because there's like half a dozen products out there, so you can use Kiwis.
Your preference, maybe.
So I can tell you what I did, which was not necessarily the best thing, but I did consult some security experts. So there were 2 places we kept, I guess 3 places we kept secrets, each for a different kind of use. So we made encrypted EBS volumes that were dedicated with the secrets, like literally like nothing, like it was a whole gigabyte, but like we stored like a few kilobytes worth of secrets there, and mounted them to the right machine under correct access controls. The kind of source of truth was LastPass, like with proper permissions on the LastPass. And for the correct secrets, you would download them to your laptop if you needed to run the script directly from your laptop. And again, like the correct secrets, and you were supposed to keep your laptop reasonably secure. But again, there's like a lot of ways you can accomplish these things.
Thanks.
So I have a AWS question. Actually, I was working on this today, so if anybody wants to pair with me at some point later, that would be great. So I am doing something with Ansible. I had to change our dynamic inventory. So what that is a quick summary is it's a Python script, really short usually, it doesn't have to be, that actually reads from Amazon. And then from that, it reports JSON output. And that's an actual list of your inventory. I had to change something, and I actually have a bug with my authorized SSH key. So if anybody afterwards wants to help me debug something, I can actually say, hey, boss, I did get that done today, even though I went down south and did something else. So yeah, pair with me afterwards, or I have a question if you have the answer for what I'm stuck on.
Sure.
Cool.
Any more questions? Cool. Thank you very much.
Thank you for that really cool talk. That was awesome. I personally have a great interest in AWS as well, so that was very valuable. We have a lot of holes, seats that are open, and we have a lot of people who have to stand. So if you can be inviting, if anybody wants to sit down, feel free to find a seat right now. Now's a good time. After PyCon, yeah, point out a hole if anybody wants to sit and be friendly and say, come talk to me. During PyCon, what you typically would do, yeah, there's a seat right here. We have some people pointing out holes right here. That's awesome. Make everyone comfortable so you don't have to stand. During PyCon, after talk, you would typically get up and go to find another talk or sit in the same room. So this is the time if you want to stretch for a second and or go find another seat, that's great. So if anybody knows anything about regular expressions, then you're going to really, really appreciate this talk, I think. And if you don't know what a regular expression is, now's the time you're going to get to find out, because Al is going to be our, last name rhymes with dirt. Sweigart. I've always said Sweigart, but I didn't understand where you said last name rhymes with dirt. So, all right. So Al's going to tell us all about regular expressions and how to use them. So everyone, welcome Al. Still room, lots of seats right here if anybody wants to sit down.
All right. Very good. Okay, good. All right. Yes, it's time to start my presentation, which is entitled, Yes, It's Time to Learn Regular Expressions. Hey, I'm Al Sweigart. If you've heard of me, you've probably heard of my book, Automate the Boring Stuff with Python. I've also written a few other Python books for beginners. All of these books are available online for free to read under Creative Commons licenses, so you can check them out. And this presentation right here is available at bit.ly/yesregex, so you can just download that right now if you want to follow along. So regular expressions have this, regular expressions, they're used for text pattern matching, and it's a really powerful feature, but a surprising number of software developers just kind of put it off and avoid learning about it because it seems kind of complicated. It's a lot of weird syntax and punctuation marks and everything like that. But you should learn regular expressions, one, because they're very powerful, and two, because it's really not that hard. We can learn all of it or at least all the basics of it in 30 minutes. So let's go. Yes, it's time to learn regular expressions. The first thing that you'll learn is that they're also called regex for short. So here's an example. We have two numbers. This is actually the same number twice. Now, one of these numbers is a phone number, and the other is the population of the continent of Asia. Which is which? Well, if you're like me, you've memorized every single American phone number that exists, and therefore you can recognize that the top one is one of those phone numbers. No, that's not how anybody actually recognizes anything. We know it's a phone number because, well, we know it when we see it. It looks like a phone number. It has a specific pattern. And what regular expressions allow us to do is specify a pattern to look for. And it's also really easy. In Python, it's 3 lines of code. The first line is just importing RE. This is the regular expression module. It's part of the Python standard library, so you don't have to install anything. It's in every version going back to Python 2 point whatever or 1 point whatever or something. It's going to be in every version of Python. There's no changes between Python 2 and 3 with regular expressions. The second line is re.compile, the compile function. This is what you pass a regular expression string to, just sort of defining the pattern that you're looking for, and this will return a regular expression object. That regular expression object has a search method that you'll call, and you'll pass I call it the haystack string, because whenever you're looking for strings, you're looking for the needle string inside the haystack string. That's just because it's easy to get those confused. So you pass the haystack string to search, and then that returns a match object, and you call the group method on that match object. So yeah, did I say 3? I meant 4. 4 lines of code that you need. But really, it's just 3 lines of code. It's compile, search, and group. Compile, search, and group. It's really easy to remember. And if you're scribbling notes down, remember that this slide deck is on bit.ly/yesregex, so you don't have to write it down unless you're just writing it down to help you remember it. That's a great way that I use to help learn things. Another great way to learn regular expressions is to say, yes, Glenn, I will give a talk about regular expressions. April 27th is so far into the future, I have plenty of time to prepare for that. Right, so let's focus on the string that we passed to compile. This is going to be in the regular expression syntax. This is the punctuation crazy syntax that is really intimidating to a lot of people. But first, let's go back to that phone number. So how do we know what a phone number looks like, or at least this very simplistic, for the sake of this presentation, this simplified representation of a phone number? Well, it starts with a digit character, that's 0 through 9, and then it's followed by another digit character, and then another digit character, and then a dash, and so forth. And this is how we can tell, oh, this is a phone number. It matches this pattern, but we have to translate all of this into code. So something we're going to pass to the compile method, or the compile function. So in the regular expression syntax, /d represents a single digit character, 0 through 9. So this is actually a normal slash, so we're going to need to make this a raw string, because otherwise it'll be //. This isn't like /d, like /in is a new line character. You actually need a literal slash. And if you don't use a raw string, then you're going to have all these double slashes making your string really look ugly. So I always pass a raw string to compile each time. Right, so a digit character followed by a couple more digit characters for the area code, and then a dash. We're actually looking for just a static dash, so we can just put the dash character itself into the pattern. That will represent a dash. And then the rest of it. This is the regular expression string for a phone number. 3 digits, dash, 3 digits, dash, 4 digits. And it returns a regular expression object. So that regular expression object has a method called search. We pass the string, maybe it's a document or something like that, that has a phone number, that pattern that we're looking for, but we want to find the actual numbers of that phone number. So we call search. This will return a match object. If the pattern isn't found in this string, it'll actually return none, so we always have to check if that match object pattern is none, and if not, then we just call group. And that returns a string. That's the exact string from the original text. So we said we were looking for a phone number, looking in this string, then we found the exact numbers of that phone number. And this might seem really complicated, compile, search, group, but imagine if you had to write this code without using regular expressions. I did. It looks like this. And remember, this is for a phone number, like that one simple phone number format. That's a lot of code. It's really basic code, but it's a lot of it, and it's not very readable. So regular expressions are a huge time saver once you've learned the syntax. So yeah, so about that /d, that's what we call a character class. It's sort of a representation of a certain character that we're looking for. /d in this case is a digit, 0 through 9. There's also /w, which has letters or numbers. Those are the W is for word characters. And there's also /s for space characters, white space characters like space or tab or new line. And then also, if you're looking for something that's not a digit or not a word character, you can use the uppercase version of that DWS to search for those characters as well. These are just like little shortcut things because it's so common to be looking for a number or for an alphanumeric character. But you can also create your own character classes with these square brackets. You just put all the characters you're looking for inside those square brackets. So say we wanted to find vowel letters, A, E, I, O, U. We can just put A, E, I, O, U, both the lowercase and the uppercase, inside those square brackets. And then if we wanted to match things that weren't vowels, just like the consonant letters, we put a little caret symbol at the front of it. And this matches everything that's not a vowel. Now keep in mind, this is matching everything that's not a vowel, so it's matching all the consonant letters, but it's also matching numbers, punctuation marks, everything like that. Speaking of which, so it's not actually looking for a caret symbol. That's just sort of telling the regular expression we're looking for not these characters. Punctuation marks in regular expressions often have special meanings. Oh, wait, got ahead of myself. And if you want to look for a certain range of characters, you can have 0-9 or A-Z to look through for all of those characters. In this case, this is the alphanumeric character class, same as /w. And so the dash here and the caret there, those are actual punctuation marks with specific meanings. Most punctuation marks in regular expressions have some sort of significant meaning. But if you want to look for, say, a literal parenthesis, just escape it. Put a slash in front of it. Remember, use raw strings because otherwise, if you wanted to escape a slash, then that would end up being 4. Yeah. Anyway, it's crazy. So if you just have punctuation marks, put a slash in front of it to escape it. So here we're just looking for, hey, I want to match an opening parenthesis or a closing parenthesis. I don't want it to use the special regular expression meaning of those parentheses. Oh, what's that? Right. Oh, yes. Anyway, right. So that's what we're looking for, the type of characters we're looking for. There's also a way that you can specify a quantity of characters. So we have all these /ds, which is really repetitive. There's a sort of shortcut that we can apply just by having curly braces with the number of characters we're looking for. So in this case, here's the sort of pattern to these regular expression patterns. Here's before is what you're looking for, in this case, a digit character. And then what follows is sort of the quantity. So whenever the regular expression has this quantity right here, it's looking at the thing behind it to see, like, oh, I want exactly 3 of this thing, which is just a digit character. And regular expressions have tons of these. I'm just going to kind of gloss over all of these. I mean, if you don't have any of them, then it's just going to be, say, right here, 1 digit, or maybe 1 or more digits, or somewhere between 3 and 5 digits, if you want to have, depending on what pattern you're trying to match. And remember, it's always looking at the thing before the quantity specifier. So we can change this to look for, say, 1 or more space characters, or 1 or more vowel characters in a row, anything like that. So, and now for something completely different, I'm going to talk about grouping by talking about Japanese. So Japanese letters are usually follow a consonant-vowel combination. So a Japanese word like sayonara is made up of 4 Japanese letters, sa, yo, na, ra. So it's this consonant-vowel, consonant-vowel, consonant-vowel. And so let's create a regular expression that matches that. Here we go. Something that's not a vowel, yes, that includes numbers and punctuation marks, but let's just pretend it was the consonant letters followed by a vowel, and then that plus sign, which means 1 or more of the thing behind me. This actually has a slight bug because, remember, this is the thing we're looking for, and this is how many. So this is actually just going to match only 1 of the non-vowels, and then 1 or more of the vowel character. So it would end up matching stuff that looks like this, like sa. It doesn't have to be the same vowel. It can be any of those vowel characters. So something like this, which I'm not even going to try to pronounce. Oh, whoops. So the way that what we really want it to do is say, no, I want one or more of both of these things as a group. And in order to do that, we can just use parentheses, which have the special regular expression meaning of grouping these things together. So now it's saying one or more of this group. And this group is just made up of a non-vowel character followed by a vowel character. And so you can see you can put groups inside of other groups and then have different quantities for everything and just make this as complicated as you like. So this is now going to correctly match. This isn't a Japanese word as far as I know. Sa, 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 this consonant vowel pattern. But it will also match a real Japanese word like sayonara. Now, thematically, this would be a great place to end my presentation. But we're not going to do that. We're going to keep going on with a few more examples. So here's another example, comma-formatted numbers. This is, you have some document, and it has all these comma-formatted numbers in it. You want to find those numbers and pull them out. So you need to find that pattern. So let's sort of think about what exactly this pattern looks like. Well, you would have 1 to 3 digits, and possibly followed by a comma and 3 digits after that comma. And you'd have 0 or more of those groups. So here in English is the description of what we're looking for. Now, I'm going to do something that is highly ill-advised for any presentation, and that is a live demo. So I'm going to Alt-Tab out of the PowerPoint presentation. Now let's do some live coding. And I also want to show off this site. There's a ton of these types of sites. It's basically called a regex tester site or a regex buddy site. And these are really handy if you're ever just trying to play around or if you're just learning about regular expressions, because you can have some text, say like this. We're going to find a comma-formatted number. So I have a 65 million year-old egg. And then we can start playing around with, okay, I have this idea of what the regular expression I need to match that comma-formatted number. It was going to be, the digit, 3 of those. And as you're typing this out, 1 to 3 of those. And as you're typing this out, it will update in real time, just showing you what this regular expression that you've typed so far is actually matching. So if you're ever running some code and you're realizing that your regular expression isn't working for some reason, you can use a site like these. There's also one called, I think, pyregex.com. There's a whole bunch of these out there. And they're really useful tools if you're just trying to get around a regular expression. So let's see, that's that first thing. And then we have the group, and I'll have a comma, and then exactly 3 digits right there. Oh, and it's going to be 0 or more of this group, so I'm going to put the asterisk, which stands for 0 or more. And now you can see I'm definitely matching it. I can just copy and paste this regular expression pattern back into my code. All right, hey, nothing failed, which is great considering that this live demo requires the Wi-Fi to work. All right, so yes, pyregex.com. That's the regex buddy specific for the Python framework. I think actually this website is for JavaScript, but once you learn regular expressions in one language, they're pretty much the same going between languages. There might be some changes for the more advanced features, but for the most part, once you learn it for Python, you've learned it for every other language as well. So, and now for something completely different, alternatives with pipe. Right, so here's a sentence from the Monty Python spam sketch. Let's write a regular expression that can match these sentences. I've removed the spaces just to make it a little bit easier, but we have an example like egg and spam, or egg, bacon, and spam, or egg, bacon, sausage, and spam, or spam, egg, spam, spam, bacon, and spam. That one only has a little bit of spam in it. And okay, so we want to write a regular expression that will match this. It's basically finding some combination of those 5 words, egg, bacon, sausage, spam, and in any order, just one or more of those words. And so, we could try writing something out, maybe something like this, but this doesn't actually work. I mean, we have egg followed by the plus sign, which means 1 or more. So 1 or more egg followed by 1 or more bacon. But what if bacon comes before the egg? This isn't really going to work for what we want to do. So instead, let's think about the character class for vowels. I mean, that's sort of what we want, except the character class can only match individual characters. So this is the character class that just represents one of those characters there. We kind of want that except for an entire group or an entire word. Egg or bacon or sausage or and or spam. So we can use the pipe character, which basically has the meaning of or in this case. If you've used other programming languages, the pipe operator is usually the Boolean or operator. And so we would have a regular expression string kind of like this, where we have egg just contained in its own little group with a pipe character, meaning or bacon, or sausage, or and, or spam. We put all of that into one big group, which basically means any of these words combined together. And then we have a little plus sign at the end of it saying one or more of that group. So that'll match any of those silly sentences from the Monty Python spam sketch. And then finally, okay, so going into, this is great, the dot character. The dot character is sort of like the God character class. It will match any character except for the new line. There's also a flag that you can pass that will match the new line character as well. But it basically matches anything. And you can combine this, if you caught this several slides back, the star character, which is one of those quantity characters that means 0 or more. So you can combine those together to create dot star, which basically means match whatever. This will match any character and then 0 or more of that any character. So this basically matches whatever pattern you want. There's also a slight variation on this. It's dot star question mark, which basically means the same thing except match the least amount of whatever. So dot star is what we call the greedy version of this, and dot star question mark is the non-greedy or the lazy version of this. And I'll show you the important difference between this. So say you're searching strings that look like this, and you want to find the pattern of anything in between those angle brackets, kind of like HTML, say. If we compile that dot star with the question mark, this is the lazy version. It's going to match the shortest string it can in this entire, in that bit of text. So it would match something like angle bracket to serve humans, angle bracket. But if you had the greedy version, it wouldn't stop at the very first angle, closing angle bracket. It would go ahead and keep searching to see if it could match even more. So this would match something that's even larger, like, say, angle bracket to serve humans, angle bracket for dinner. Angle bracket, ooh, plot twist. So the non-greedy version would stop at the very first chance it got once it actually completes the entire pattern. While the greedy version will go ahead and continue. It will stop here if it can't match anything larger than that, but it will continue to check the rest of the string to see if it can match an even larger string. Right, so I mean that's all the basics of regular expressions. You kind of know enough to actually dive into the documentation and figure out all the other like ins and outs, but those are all just minor details. Let's just go over some best practices with regular expressions, and specifically this is what regular expressions can't or shouldn't do. And the main thing is don't parse HTML with regular expressions. I know going back to this thing, I was like, hey, angle brackets, that's kind of like HTML. Yeah, you don't want to use regular expressions to parse HTML because HTML is actually really complicated. So you can have HTML tags can have all sorts of like weird white space or weird attributes that you're not expecting. It's a lot more than just like, oh, 2 angle brackets and whatever matching in between them. If people don't have HTML entities, if they're not using that properly, you can have some like extra angle brackets suddenly appear and something else. And suddenly, you're writing this really simple, like, oh yeah, just angle bracket and then match whatever an angle bracket, and then you'll find some case that doesn't work, and then you'll write a fix for that. You'll make an adjustment to the regular expression, and then there'll be some other little case that doesn't work, and so on and so on. You really don't want to use regular expressions to parse HTML. Instead, what you want to use is an HTML parser, such as Beautiful Soup 4, I think is the latest version. And they've taken into account all those little details. The second thing is, well, this was an interview question I had. I asked a candidate once, oh, great. Come up with a regular expression for strong passwords, something that has uppercase and lowercase and numbers and punctuation marks. And the regular expression to do this is actually incredibly complicated because you have to take into account what if the lowercase letter was after the uppercase letter, but before the numbers, and all those different combinations of the different orderings. What you really want to do is just have several different regular expressions, one that checks, oh, are there lowercase letters, and then another one that checks, are there uppercase letters, and another one that checks for numbers and special characters. My point here is basically if your regular expression that you're writing is getting super huge and convoluted, and you're trying to capture all these different combinations of things, there's probably an easier way. So that's just a sort of like a little code smell if your regular expression is getting super huge and complicated. And the next thing is matching nested parentheses. This is great. So you have like a string with nested parentheses, and you want to use a regular expression to see if they all match. Like you have one open parenthesis for every closed parenthesis, and they're all in the right order, so they're nested correctly. Technically, regular expressions cannot do this. It's absolutely impossible for them to do it. Regular expressions don't have flow control. There's no if or else or loops in regular expressions. They don't have variables or data structures to really track things. Technically, Python regular expressions do with backtracing and all these other little features. But essentially, this is an impossible task for regular expressions. And to dive into computer science a little bit, technically, regular languages, which are the type of language that regular expressions follow, aren't Turing complete. And if you wanted to find matching nested parentheses, you would have to have a context-free grammar. And the reason I know all of this is because the last job that I was working at, I was in a code review with some coworkers, and we were looking at this web app that had a field where a user would type in a regular expression. It was for some, like, if network traffic matches this regular expression, then we want to block it, or something like that. And my coworker said, hey, we want to validate this field so that they're typing in a correct regular expression. Is it possible to write a regular expression that can match regular expressions? And I said, no, it's not, because you need a context-free grammar, because regular expressions are only regular languages and blah, 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 all these other details. And that I remember this because it's the one time my computer science degree was actually used in real life. Yeah, you like that answer. You better, because that answer cost me like tens of thousands of dollars. Right, so you can't use regular expressions to match regular expressions. Again, regular expressions are really powerful. They're not going to solve every single problem you have. That's what we have programming languages for, like Python. Anyway, that's it for my talk. I adapted this for 30 minutes, but I guess I could have added a bunch more content for this. Anyway, if you want to learn more about regular expressions, the Python documentation for regular expressions is actually really good. There's also a chapter on it in Automate the Boring Stuff with Python, which you can find online for free and read that. It's automatetheboringstuff.com. Thank you very much.
Are there any questions?
Oh, sure.
Linux often said if you want to delete an empty line, usually you start to caret and a dollar sign. I mean, starts and end are the same.
Oh yes, so that's a
regular expression. How do you what do you use for the beginning of the line instead of caret?
You do the exact same thing. This is great. I can actually use this website. So say I wanted to. Oh yeah, so the question is, I think in like Unix command line stuff, you can use a caret to match the, say I want to look for this pattern and I want to make sure it starts at the beginning of the string. So let's say if I was looking for year, it would match this right here. But if I wanted to say, oh, I want to actually match it only if it's at the very beginning of the string, I can use that same caret right here. And now it'll only match year if it's at the very start of the string. And then conversely, you can do the same thing with the dollar sign at the end of it. And that'll match year only if it's at the very end of this. And you can also combine these together, which is kind of nice, caret and dollar. And that'll say basically the entire string has to match this this pattern that I'm saying. So like it would only match it if, I don't know, let me use a slightly more, let's say a digit character and then one or more of those. So this would match a number, but only if the entire string was a number. If we had like a letter A in the middle of it, then it doesn't match at all. And then an easy way to remember, I always forget which one of these comes first. So I just remember the little saying, carrots cost dollars. So carrots come first, then $sign at the end. But yeah, regular expressions are surprisingly the same and similar between languages. So the whole regular expression syntax for Python is basically the same thing as in Unix command line tools and everything. I mean, regular expressions basically go back like 40 years and then some. But yeah, next question.
Thank you so much for the wonderful talk. It's nice to see that you're as dynamic as your books, and your podcast, and your appearances. Wondered, we're dealing entirely with ASCII here, but can you talk a little bit about Unicode and how regex works with that?
Yes, so...
That scares me.
Unicode scares everybody, but there's also a great talk by Ned Batchelder called Unicode, How Do I Stop the Pain? Which is great. He actually explains everything you need to know about Unicode and what Unicode is and the differences between Python 2 and 3. And it's kind of the talk that made me realize Python 3 handling Unicode properly is a great reason to move on to Python 3 just for that. So for Unicode, I believe you can do the exact same thing. I mean, like if I'm writing a pattern and I want to match the word, like the literal word cat, I can just type CAT right here. If I have Unicode characters, and so I have this small program that automatically copies the look of disapproval emoji or emoticon to my clipboard because I use that emoticon often. So I think this basically works the exact same way. You would just use the Unicode characters just like you would use any of the ASCII characters as well.
And like digit groups or words or spaces or things?
Oh, yeah, when it comes to that, where like the definition of a digit, I think, but I can't confirm that it might depend on your locale settings for what counts as a digit or like what counts as a letter. Like, I mean, what if I have this word character plus, okay, so I guess, and I guess underscore also counts as a word character. I should update my slide.
But
underscore is a slash. Yeah, like whatever character this is, I think, is it Sanskrit or something like that? I guess because of whatever locale settings in my browser, it doesn't count as a letter in this case. I'm not really sure. I haven't dived down to that detailed of a level, but I think it's basically look at your locale settings.
Thank you so much.
Thanks. Oh. So everything that's not a word character. So that's all the spaces and punctuation marks. And I guess, yeah, that does correctly identify this character. Yeah, next question.
Hey, great talk. Thanks. So recently for work, I've gotten into Node.js. And like there's this really big security concern in Node.js that I've never heard of before called regdos. And I was wondering if like it's a thing in Python.
I've never heard. Is this like kind of like zip file bombs?
I'm not familiar with it. It's like a regular expression denial of service.
Right.
So,
okay. I've never heard of this, but I can immediately kind of figure out what it is. So I know zip file bombs, which are zip files that are specifically constructed so that when you unzip them, they become like a 4 terabyte file, even though like as a zip file, they're like 2K or something like this. And so you can upload the zip file to some web service, and then when its backend automatically unzips it, it just eats up the entire server. I'm guessing the regular expression bombs would sort of be the same thing. I haven't looked into this at all. It's kind of an interesting idea. I can't really... I guess so, because... Oh, do you know how... Oh, what?
Yeah,
oh, greedy,
it has
yes.
to do with greedy expressions. Yeah, that's what it was.
The reason is because Node isn't really thread safe, and so they don't release any thread locks. And so if you give it like a really expensive regex, okay, sure.
When Python matches regular expressions, it releases the GIL, so all threads can continue running. That thread will be blocked on something really expensive, but like the whole VM isn't necessarily frozen up. Node doesn't have that advantage.
Oh, okay. So this isn't necessarily a problem on Python.
It's not necessarily a problem as long as you sort of do your thread stuff right, if you're doing thread stuff.
Ah, yeah. Okay.
But V8's not thread safe. Okay.
Okay. Oh, wow. Thanks a lot.
Cool. Thanks.
You studied computer science. Did you study Backus-Naur notation, and do you consider that a relevant form of regular expression notation?
Yes, I did, and that was a decade and a half ago. And really, it was just that one thing. No, I've used my computer science degree a lot. I mean, as far as regular expressions, there is a whole computer science aspect behind regular expressions and regular languages and automata theory, and it's really interesting. But what's great about regular expressions is there's this huge practical side to it as well for doing text pattern match recognition. And so the Backus-Naur form, I don't think it's, unless it's used in sort of like actually generating an abstract syntax tree by parsing an actual script or anything like that. But I don't really remember that specific notation. And so I don't know if there's any like libraries that are using it. Oh, okay, yeah.
I have a question about how to reason with the computation complexity of a regular expression. And a specific question is about if, let's say, I have a 0, 1, like either 0 or 1, and with a plus in the end. If I group together with another plus in the end, if I'm matching that with a string, what will be the complexity? How do I reason with that?
Oh, so if we like had 0, 1, and then plus,
yeah, maybe
something like this.
Yeah.
I mean, I guess technically you'd have to just sort of take it one step at a time and starting from the inside out. So in this case, it's 0 or 1, and then 1 or more of these digits. And then I guess 1 or more of these digits, but I think this sort of, the extra plus right here is just sort of redundant.
But this is a two cycle there's a two cycle in this regular expression. What if like when it's matching, it probably want to like, well, 0, 1 multiple times, and another round multiple times, then it will back one character and try to do another round. So it seems like there will be a lot of rounds was trying in there.
Yeah, I don't know the performance characteristics for regular expressions.
Actually,
I haven't been
Then one I tried in a interactive session. It would take a really long time to matching an unmatching string.
Oh, yeah. Oh, right, yeah, if the pattern never appears, and so the regex is basically searching the entire string.
Increase the complexities.
Yeah. So, I mean, in all of my software, I've never found a performance problem because of regular expressions, but then again, usually it's something really tiny. And also, this is sort of the thing that would get flagged during a code review, saying like, oh, well, this plus is kind of completely superfluous, so we would just simplify it down to this. But I guess if for whatever reason you had like user input, had regular expressions as user input, like in that example of the user enters a regular expression for network traffic to block or something like that. Yeah, I don't know of any modules that would like simplify or anything. Oh, do you have?
I think they get compiled to state machines, and then the state machines are optimized before you even.
Oh, okay. Oh, okay. So there. Oh, okay. So there is an optimization round. Yeah, and so that's the like computer science aspect of this. I remember.
Inherently backtracking and back references, having lots of candidates that you parse will kill performance. So just because something can be written as a regex, you may not want it.
Oh, okay. So anyway, I forget exactly. I think it's maybe match objects. The representation, if you just look at it, the representation form, so you'll usually find something that says like SRE Labs, which is, I think, the original group that created Python's regular expression module like 20 years ago or however long ago it was. But I don't know. I'm not familiar personally with the like performance characteristics or what optimizations they do for that. But yeah, any more questions? Oh, all right. Thanks a lot.
So if somebody was asking for a talk and said, look, I'm really looking for a talk that's on meta classes in Python, and I want it to be simple, and I want it to be clear, and I want you to be able to take me from step to step, build on each thing, and have me completely understand it when you're done, my answer would generally be, yeah, and I want a pony. But If you were to say the same thing about regular expressions before tonight, I would have said the same thing. However, I thought Al just nailed it. It was very clear on regular expressions. Started from the beginning, built it up, and I'm going to probably use that several times to refer people and actually refer to myself, because I get my poor old brain gets quite confused, whether it's like, oh, okay, if we're matching new lines, I have to do the not the dollar, I don't know, and so really good. Thank you. Okay, so typically what we had another speaker tonight who wasn't able to make it, so we actually have a little bit more time. It's about 30 minutes. Our regular meetings, we would actually do announcements, and we would also take a little bit of time to have some just mingling and some random access. But because this is the theme of Python, while we're doing announcements, here's just something to think about. Does anybody think they could do a 5-minute lightning talk, just like PyCon? You have 5 minutes to speak about any topic that you want, Python related, of course. Is any volunteer would like to do that? Raise your hand. Oh, come on. 1. Any other volunteer? Okay. 2. So we'll have 2 lightning talks. That's 10 minutes, and that'll pretty much be perfect time for us. All right. So while you guys are, do you need time to prepare? Time to prepare? All right. So we'll do our first lightning talk. Come on up. Need the mic?
We got HDMI?
We do.
Is this HDMI?
It is. I believe. Oh, here we go.
Do you have HDMI?
No.
Oh,
no worries.
sorry.
I can probably do it without slides, too.
Okay.
Yeah. Hello, everyone.
Sorry. What's easier?
You're good. You're good. Hi, everyone. My name is Mahmoud Hashemi. I'm looking forward to seeing you all at PyCon, those who are going, and for those who couldn't, thanks for coming out. I wasn't planning on talking tonight, but I am giving a talk at PyCon Web, which is a web-focused PyCon. It's in Germany this year, and I haven't prepared my talk yet, but it's about URLs. So a lot of people take URLs for granted. You probably signed up for this meetup on a URL, and you're probably thinking about URLs you could be reading right now instead of sitting listening to me talk. But basically, URLs are just part of the fabric of society now. Kevin Mitnick, he's a famous hacker. He went to prison for many years. Eventually, he came out, and he said the one thing that surprised him was that he could look at a billboard and he could see a piece of the internet leaking out into reality. And those are my words, not his. I'm sure he said it much nicer. But the point is that they've pervaded everything around us, and so we sort of start to take them for granted. But URLs are actually very, very complex. The URLs have been defined in over a dozen RFCs, hundreds of pages, thousands, tens of thousands of hours by people paid much more than myself. And yet we still sort of run around bandying them about like they're just text. But they're very complex. RFC 3986 actually defines a regex for URLs, and yet I still see people splitting them on slashes and sort of sticking Unicode characters into them willy-nilly and not encoding them correctly and so forth. So I saw this enough that I actually started writing a Python implementation of URLs, and I sort of hit a pretty big snag and got stuck for 2 years. Now, anyways, recently I revived this interest and I reread the RFCs and I re-implemented URLs, and now I have two implementations of URLs, one which is immutable and one which is mutable. The immutable one is called hyperlink, and the mutable one is in a utility library that I distribute called bolt-ons. But basically, if I had slides and if I had, a projector and so forth, I'd probably bring up the docs. You can go read about hyperlink and some of the background. What is the difference between a URI and an IRI? Raise your hand if you know the difference between a URI and IRI. Okay, so one person who probably, okay, Moshe, I trust you. Yeah, so a URI and an IRI. They're both URLs. So it actually ends up being very confusing. So W3C actually issued a statement, right, that we know that this is confusing and everyone should just call them URLs for now. We don't want people going around being pedantic, correcting each other. That actually, that's an IRI and not a URI. So the difference is pretty simple as I've sort of defined it. One is for network transfer and the other is for human display. So sometimes in your browser you see it says UTF-8 equals check mark. Or something cutesy like that. TSA, pre-check, we live in the wonderful governmental society. Okay, so anyways, yeah, but anyways, so if it has a Unicode character that looks like Unicode to you, then that is an IRI. And if it has a bunch of percent signs in it and not a single Unicode character to be found, that's a URI. It's actually much more complex than that. But a URI is meant for going over the wire, and so you're going to encode it all the way down to pure ASCII. And if something is for human consumption, it's probably best that we make it international and then consumable by all. And so that's an IRI. It's more complex than that, but like that's why it exists in code, and you can just pip install a hyperlink and import it and be off and running. Anyways, so yeah, that's what I got for now. Good for lightning talk, I think. All right, thank you. Give it up for Al, yes.
Hey. Hello, fellow PyCon attendees. That'll make more sense when I'm at PyCon. Yeah, so this 5-minute lightning talk is basically how to meet people at PyCon or other technical conferences or events and meetups like BayPIGgies. So this is just a bunch of information that I kind of collected, and I'm only half remembering it right now. But I found that it's a really great way to actually go out and meet people, because going out to meet people is sort of the main reason why you're here. Like PyCon has tons of great talks, a lot of great knowledgeable people presenting useful information, and you should just skip all of their talks. Just don't even go to any of them, because what you want to do is, one, they're all video, they're all recorded, so you can just watch them online later. But two, one of the great things about PyCon is that you can just like hang out in the hallways and just meet random people. But all of that is going to be lost if you just hang out in the hallways and not talk to anyone at all. So there's the one main trick that I have for going out and meeting people, because I have like that first awkward shyness where I don't want to talk to people, and then I have to like decide who I'm going to talk to, and that's actually kind of problematic because my internal biases will automatically make me want to talk to somebody who's my same gender or my same age range about, or same, like, I don't know, they look like they like cats too or something. I'm basically going to try to find somebody who reminds me of myself, and you don't want to do that because that's limiting who you're interacting with. So I came up with the t-shirt color trick. So think of a color that's not blue or black or gray, which are really common t-shirt colors. Just think of a color like green, and then find the closest person to you wearing that t-shirt color, and then just say, hey, how's it going? How's it going? And if that doesn't work, then you just come up with a different color, like pink or something like that. But anyway, this really forces you, I mean, it's limiting you enough so that you don't have like, you know, if you pick like blue, everybody's wearing a blue shirt. So then your biases are going to start infiltrating again, and you're just going to pick someone that reminds yourself of you. But the t-shirt color trick is great. You can just come up with a color, and then it says, it doesn't matter whoever is wearing that color, no matter who they are, just go up and talk to them. And the second part of this is, now that you've met somebody and you've chatted with them a bit, this is going to be completely pointless if you like go home and never talk to them ever again. So what I found is actually having a Twitter account is a pretty good way. If you don't have a Twitter account, you can just get one just so that you can follow other people. But Twitter is a really nice way to just sort of keep in touch with people afterwards, because they have just like, you know, little messages or whatever, and you can see if they say something, you can reply back and just slowly build up rapport. It's less direct than like writing them an email after the event or something like that. And anyway, so if you want people to know your Twitter handle, you should probably write it up on the wall, like I should have done that like Moshe did. But you should also have a business card. Like, remember to bring business cards to these meetups. And your business card, I have mine right here. Basically, you can design your own business cards and get them printed out really cheap. My tips for business cards are, one, order the smallest quantity possible, because I would think like, hey, if I buy 500 business cards, then it's cheaper per unit, and then you hand out about 30 of them, and then you realize you want to order new business cards because you're getting sick of the design that you have, so then you throw all those old ones away. But anyway, business cards, and the things you should have on your business card is your name, your email address, and maybe like your Twitter handle, And that's pretty much it. Maybe like a URL if you have a website. Don't put your phone number, don't put your address, like your home address on it. Basically, if somebody took a picture of your business card and posted it on the internet, you should be totally comfortable with that. And what's also great about this is it kind of future-proofs your cards, because if you move or you, say if you get a new phone number or something like that, you'll then have to throw out all the old business cards and then buy brand new business cards with the new updated information on it. Anyway, yeah, so that's it. Remember to bring business cards. Pick a t-shirt color to talk to people, follow up with them, get a Twitter account, even if you never post anything to it, and just start meeting up. So right now, just pick a side, left or right, and say hi and tell them your name, like right now. Get over the awkwardness of talking to people. Yes, and yeah, and so keep mixing throughout the rest of this. All right.
What an incredibly good segue. No, keep going, keep going. What an incredibly good segue. So let's quickly do announcements, and then let's start practicing what we just learned. All right, so here's where we have an announcement right up here from our somebody who's awesome, from one of our great hosts that actually helps us all the time get free space and free food. Yeah.
I just wanted to say, instead of business cards, just find each other on LinkedIn.
Should we put LinkedIn on the business card? Yeah, all right. Good.
And someday you'll be able to scan their irises. I'm with the SFB ACM, and we've got a seminar coming up on May the 6th on Spark with Scala, for anyone who's interested. It's not Python, but we're not trying to evangelize you, so don't worry.
So I want to announce a fairly new meetup. It's called Peninsula because we're in Peninsula. So it's between San Francisco and San Jose, so everybody can come. Our next meetup, we had a meetup in April a couple of days ago. We are skipping the May meetup for the obvious reason, Python. But we will have a meetup in June. It's already up on the website, so if you just look for Peninsula on meetup.com, feel free to come. It's a nice location. Yeah. Redwood City.
Boxes, offices, Redwood City, Caltrain, June 22nd? Something like that.
20-something. Find it on the website.
Any other announcements? Including the ones where you might be looking for a particular person to hire for a job? Maybe? Anybody hiring? Raise your hand. Wow, this is so not the typical. Yeah. Someone's not hiring. That's like so rare. It used to be like all the time. All right, is anybody looking for work? You want to say a word? Nope, okay. So, all right, we won't go there. That's awesome. So if you're looking for someone, there might be someone around here. If you want to start seeing what they do, that would be great too. All right, so we've had a great introduction on how to get to know someone. We have about 20 minutes before we need to close and exit. So you found someone on your, was it right? Is that right? Was your find someone on the other side and talk to them. Great. Thank you, everyone.